Hello everyone, welcome back to the final part of our mini-series on sleep and GPA in SPSS. In part 1, we built a hierarchical regression model step by step. In part 2, we checked the key regression assumptions. And now in part 3, we'll interpret the SPSS output to answer our research question, which was, does sleep quality predict GPA even after controlling for gender, major, and caffeine use? So without further ado, let's get started. Go ahead and open up the output of your SPSS file. I have pasted the outputs here in the slides for you for the convenience. So first, let's look at the model summary table. Model 1, which included gender and major, and by that we could explain only about 2.6% of GPA variance. It is very small. But for Model 2, when we added PSQI, or a sleep quality index, over gender and major, R-squared jumped up to about 35.7%. And that's a huge improvement, which shows that sleep quality contributes a lot of explanatory power. And in Model 3, when caffeine use was added, the amount of GPA variance explained by all of the predictors didn't change at all and stayed at the same amount as Model 2, which was 35.7%. So we conclude that there is no extra predictive value from caffeine. And now already we see the key results, which are sleep quality matters, caffeine does not, and the effect of major and gender are not noticeable, right? Now let's move on to the ANOVA table. Model 1 with only gender and major was not statistically significant. You may ask, where do I know that? From this, the p-value. The p-value is greater than 0.05, so we failed to reject the null hypothesis. The null hypothesis here is that major or gender are statistically significant, so we reject that. Then Model 2 become highly significant after adding PSQI, sleep quality index, into the research. And Model 3 stayed significant overall, but without improving fit. So this matches what we saw in R-squared changes, which says the real action is when PSQI enters the model, right? Next, let's interpret the coefficients table carefully. For PSQI score, the coefficient is about negative 0.074 and highly significant. Look at the p-value. That means as sleep quality worsens, higher PSQI means worse sleep quality. So as I was saying, as sleep quality worsens, GPA decreases even after adjusting for other variables. And next, gender is not significant. Male vs female showed no meaningful GPA difference in this dataset. And for major, neither science nor engineering differed significantly from arts. And finally, for caffeine use, neither low nor moderate use differed significantly from high. So we conclude that the only strong and consistent predictor here is sleep quality, right? But quick reminder on how to read coefficients. I want to clarify this concept for you once and for all. So for continuous variables like PSQI, the coefficients tells us the slope. It tells us how much GPA changes for each 1 point increase in PSQI. So here, for each 1 point increase in PSQI, we expect GPA to decrease by 0.75 point on average. And now for categorical variables like major or caffeine, the coefficient compares the category to the reference group. For example, science and engineering were compared against arts. Arts here is the reference group, and low or moderate caffeine against high. Again, high is the reference group. So you see the coefficients for caffeine and major categories, and they are not significant Here you may say that 0.04 and 0.048 are not that small compared to the coefficients for PSQI, which is 0.07, and I understand that. You may ask why we consider PSQI significant but not these two. And here's the answer. The point here is that you should always check p-values before interpreting effects. If the effect isn't significant, we don't treat it as reliable. So you see the p-values for caffeine use are both greater than 0.05, so we conclude that the effects are not significant. And that's why we didn't consider major coefficients as significant, right? I hope you got it. So here's how you might summarize this in APA style, American Psychological Association. A hierarchical regression showed that after controlling for gender and major, sleep quality significantly predicted GPA. Poorer sleep was associated with lower GPA, and adding caffeine use did not significantly improve model fit. You could have also add some numbers here, especially talking about changes in R squared, but for the sake of this tutorial, I just wanted to explain everything in a simple, easy way. And this kind of reporting communicates both the step-by-step logic and the main findings the best way possible to the audience from different disciplines. So, to sum it up, a sleep quality is a strong and significant predictor of GPA. Gender, major, and caffeine use did not make a significant difference in this data set. And hierarchical regression was the right tool because it let us test predictors in blocks and see exactly which variables added real value. I would say this result mirrors what we'd expect in real student dataset, which was that lifestyle factors like sleep can have stronger impacts than demographics or caffeine use. And that was it. That was the process of running a hierarchical regression and interpreting the results of it in this mini-series. If you found this video helpful, please don't forget to like, subscribe, and drop a comment with the next type of analysis you'd like me to cover. So as always, thanks for watching, and I'll see you in the next tutorial.